Hello everybody, today we're going to be taking a look at function operations. You're going to need those guided notes from me, a calculator, and then of course something to write with. So let's go ahead and get started here. We'll start with some vocabulary. Function notation. Oftentimes functions are written in what's called function notation. So rather than write them with y equals 5x minus 3, instead we may exchange the y for an f of x. Function notation, it means the function is given a letter name and we're told that input variable. So we are told that x is in it. So this example is read f of x, and also it means that the function named f has the variable x within it. So those are two very important things, that you know how to say f of x, or you know what that means, and also that you understand that the f is really just his name and we use it to refer to which function and what is within it. So let's take a look at a few examples here. Let's start first with g of 4. According to the functions given above, we want to find g of 4, and that means we're going to take the g function and just plug the number 4 into it. So the g function is 2x to the 1/2 minus 6, and we'll take that x out and plug a 4 into it like so. And when we do that now, we have to use our rules of exponents. We're going to start right here. You use rules of order of operations. We're going to start with our exponents first, excuse me. So 2 times 4 to the 1/2 power is the same thing as a square root. So this is saying we want the square root of 4. So 2 times 2 and then subtract 6. If we then compute some more, 2 times 2 makes 4. And then if I subtract 6 from that, I'm going to go ahead and get -2. So the g function with 4 plugged into it, so g of 4, works out to make -2. Let's take a look at another example, f of x minus g of x. So we're going to take a function and subtract another function from it. We're not going to get a single value answer here. Likely we're going to get another function. So let's start with the f function. So x to the 1/2 minus the entire g function, 2x to the 1/2 minus 6. So we have to subtract both parts of that. An easy way to do that, remember, is to distribute the negative sign here. So we'd have x to the 1/2 minus 2x to the 1/2 plus a 6. Negative times a negative makes a positive. Now when we go to add or subtract anything, we need to make sure that we have like terms. I see some like terms here. They both have x to the 1/2. The first one is 1x to the 1/2 minus 2x to the 1/2 leaves me with -1x to the 1/2. Now that 6, he's a constant. He doesn't combine with any x to the 1/2. So he is just alone like that, and that's my final answer. Okay? There he is, simplified version. So let's take a look at our next example here. We're going to add some functions and then multiply some functions. So let's take f of x plus g of x this time. The f of x function is x to the 1/2. The g of x plus 2x to the 1/2 minus 6. So we're going to add here. We don't need to distribute a negative sign. So I'll just go ahead and drop down everything I have here and look for like terms again. Just like the last one, the x to the 1/2 are like terms. 1x to the 1/2 plus 2x to the 1/2 makes 3x to the 1/2. And then minus 6. So there's my simplified expression for f of x plus g of x. Now let's look at multiplication. F of x is x to the 1/2. We're going to multiply him times the 2x to the 1/2 minus 6. So when you multiply like this, we want to distribute and then go ahead and combine like terms. So we're going to distribute first that 1/2, x to the 1/2 times 2x to the 1/2. 1x to the 1/2 times 2x to the 1/2. The 1 times the 2 makes 2. And then I'll have x's. How many x's? Well, we have to go ahead and add these powers here. X's times x's, we add those powers. So 1/2 plus 1/2 makes 1. There we go. So we have 2x to the first. Now we need to distribute the x to the 1/2 in front times the -6. Well, that would just give me -6 x to the 1/2. So there's my simplified expression for f of x times g of x. Okay, let's keep going with some more examples. We've done adding, subtracting, plugging in a number, multiplying. Let's go to division. Okay, division now. Let's take a look. Division, we have h of x divided by f of x. So h of x first is the x squared over x to the 1/2. And if you remember your rules of exponents, this is going to simplify to make x to a new power. We're going to just go ahead and subtract those two. 2 subtract 1/2 is 3/2. So my answer is x to the 3/2 power. Now let's take a look at this the sixth example here. This one's a multi-step one here, so follow with me here. Let's read it from the front. From the front, this says, take the g function and plug the x function into it, or plug the f function into it. So here's my g function. And then inside right here, I'm going to go ahead and plug in the f function. So into the x to the 1/2, I'm going to plug an x to the 1/2. So inside this x, I'm going to replace him with the whole f function. So it turns into 2x to the 1/2 to the 1/2 power again, and then minus my 6. So if I were to simplify that, remember powers onto powers here, guys. This becomes 2x to the 1/4. I multiply 1/2 times 1/2 is 1/4. And then last but not least, I've taken the g, I've plugged the f into it, and then I go ahead and plug the number 81 in. So I'll go in here and I'll plug in 81 to the 1/4 and then minus 6. So now if we were to calculate this, let's start with 81 to the 1/4 power. Well, that one is a perfect fourth root. That's a 3. So this turns into 2 times 3 minus 6. 2 times 3 is 6. Minus 6 more makes 0. Woohoo! There's my final answer. Okay, so this works out to give me a value of 0 because I plug in a number at the end. I don't just leave it with x's. Okay? So when we think about function operations, there are lots of little things to know. Let's take a look at a few more like that, and then we'll call it good today. So g of x, 2x to the 1/2 minus 6. Now we go ahead and plug the h function into it. So right here, where that x is, we're going to pull him out and replace him with the entire h function. So 2x squared now goes in where the x is, and then the 1/2 power is still there, and then the minus 6. So this simplifies to make 2x. What do we do with those things again? Oh yeah, we multiply them. 2 times 1/2, that'd be 2 over 2, that'd be 1. Yay! So this is what I get for that final simplification. Do I need to plug a number in after that? Let's keep looking. Oh, nope, just keep the x's in there. Okay, we don't need to plug a number in. We're done then. Now let's look at this next guy. Ooh, we're going to get a number answer. Take the f function, plug -2 into it. X to the 1/2. We're going to stick -2 in where the x is. And then we go ahead and calculate this. -2 to the 1/2. Oh, are you getting an error? Me too. That's because this is a square root, and you can't square root a negative number. This power is a square root. So we got a problem. That is causing some issues because sometimes when you plug in values, it doesn't work out. And this brings up a big idea. The basic rules of math, you guys. You cannot divide by 0. Okay, you cannot take a square root of a negative number. You may not leave answers with negative exponents. A negative divided or multiplied by a negative becomes positive. And fractions and roots must always be simplified. So, with all those rules in mind, remember we got all these things we got to worry about when we're making these new functions. So when we're making them, we have to be careful. Because if I go about doing some things and I start dividing by functions, I have to be careful. Remember, dividing can't have a 0 in the bottom of that fraction. So right there, I have to be careful that I don't ask anybody to plug in an x value that would turn the bottom of that fraction into a 0. What x plugged in right there would make the bottom turn into 0? Just 3. So this is only possible to calculate with some x values. Which ones? All the rest, but not 3. Okay? So we're going to be spending some time talking about domain, appropriate limitations for x or appropriate x values. So like this last one, we have a problem. In the bottom of the fraction, we cannot have 0. So when does this turn into 0? X minus 3 turns into 0 when x equals 3. So that means I cannot have my x equal 3. Okay, if it does, I'm asking somebody to divide by 0, and we can't do that. We can't ever divide by 0. So my domain would be all real numbers except 3. I can't have 3 in that bottom of that fraction. Let's think about this square root right here. What's the rule for square roots? This whole thing under here can't be negative. Not a negative answer. So what numbers, when I plug it right in there, is going to give me negative answers? Well, 6 gives me 0, and I can square root 0. But 7 gives me 1, so that one's okay. All right. Well, what about 5? 5's bad. In fact, anything less than 6, even 5.9 gives me something negative in that square root. 5.9 minus 6 is negative 0.1. So we got a problem. We have to make sure that my domain stays all x's that are, think about it now, greater than or equal to 6. We want to make sure my x values are greater than or equal to 6 because all the ones less than 6 turn that guy into a negative value there. Well, this, you know what? That doesn't look like a fraction and that doesn't look like a square root. We really wouldn't have any limitations on that. So this one, the domain is all reals because we don't have to worry about any fractions or negatives underneath square roots. The next one here is a fraction. We have to be careful to make sure that this bottom of that fraction does not turn into 0. So if I want to know what x value makes that happen, I'll just put equals 0 after it. Solve, minus 3, x equals negative 3 halves, which is the same thing as negative 1.5. So I need to say x cannot equal negative 3 halves. So the domain is all reals except x cannot equal negative 3 halves. So this idea of domain, range, creating new functions based on notation, it's new. Thank you for taking good notes, and we'll continue to practice.